Hello friends, my name is Chinmay Deshpande, and this video lecture we are going to discuss about unit commitment, in that numerical on dynamic programming method. Let us consider a first numerical. Obtain the economic schedule for the two units, the production cost of which are given as follows to supply a load of 3 megawatt having a step of 1 megawatt. Use a dynamic programming method. Now the equations has been given. F1 or C1 equal to 0.8 E1 square plus 25 P1. F2 will be equal to C2 equal to 1.2 P2 square plus 22 P2. Now here we have to use a dynamic programming method. So formula for dynamic programming method is capital F suffix n x equal to minimum of y, small f capital N of y plus capital F n minus 1 into bracket x minus y. Let us first understood the meaning of these terminologies. Capital F n x, it indicates minimum cost of generating x megawatt by n number of units. Small f suffix n y, it indicates cost of generating y megawatt from n number of units. So please remember, when we write a capital F, then that will be a minimum cost of generation. Small f is nothing but cost of a generation of particular megawatt with the help of given units. And here the capital F n minus 1 of x minus y. Now as it is a capital F, so we can write minimum cost of generating. Then here in a bracket we have written x minus y. So minimum cost of generating x minus y megawatt by remaining n minus 1 units. So now let's start with this numerical. Now let us consider that here I will consider only one unit is operating. Only one unit is operating. So what we will do? Only one unit is operating means what? Here we will write it as F capital N of x. Now how we can write only one unit is operating? Here n is nothing but number of units. N is nothing but what? Number of units. So here as only one unit is operating, so we will write it as F1. Now how much megawatt we have to supply? 3 megawatt, which is given in the numerical. So I will write it here F1 of 3, which is equal to, which will be same, small f1 of 3. Now why it is same? Because if we have only one generator, then the minimum cost of generation and the cost of generation for a particular megawatt will be same. So what to do here? Now refer this equation F1. What to do here? We have to put P1 will be equal to 3. So I can write it as 0.8 into bracket P1 square means what? 3 square, because demand is 3. 3 square plus 25 into 3. So we will get answer as 82.2, and unit for this is nothing but rupees per hour. So what we did here? We considered only one unit which is operating, and here we have find it out the value for this. Now here we have to use this formula, whatever we have written. I will mark this formula as, let's say, equation number A. So we have to use this. Now what we have to do? Now consider, I will write it here as consider both the units. Consider both the units, that is unit 1 and unit 2. So what is the value of n here? Here in this case n is nothing but 2, because here we have taken both the units. Now I will substitute here in a formula. What was the formula? Capital F, then n is what? 2. Now x is nothing but how much megawatt load we have to given here? 3 megawatt. So that's why I will write it as F2 3. Here the formula is minimum of y, then small f, then here n, suffix n, so 2. Now y, here I will write y as it is, y plus capital F, please see the formula, n minus 1. So what it will be? 2 minus 1, it will be what? It will be 1 into bracket x minus y, that is 3 minus y. Now here if you see in the problem, what is to be given? Value of X is nothing but a demand. That demand is nothing but what? It is 3 megawatt, and it is clearly mentioned here that it will be increased, the load will be increased with the step of 1 megawatt. So what I will do, I will write it like this. If y equal to 0, if y equal to, now x equal to 3, which is constant. So suppose if y equal to 0, then what is x minus y? It will be 3 minus 0, which is equal to 3. Then again I will write x equal to 3 megawatt. Now suppose let's say y megawatt, y equal to 1 or 1 megawatt will be generated by the unit. Then what is x minus y? X minus y will be equal to 3 minus 1, which is equal to 2. Next is nothing but again we will take x equal to 3 megawatt. Now suppose the value of y is incremented as 2. So what is your x minus y? It will be equal to 1. And again x equal to 3 megawatt. So what is your value of y? Y will be equal to 3. Now it is incremented by 1. So 3. So x minus y will be equal to what? 3 minus 3 is nothing but 0. Now why we did like this? Because it is mentioned that your load is going to be increased with a step of 1 megawatt. So if the y is the unit which handles 0 megawatt, then x will handle 3 megawatt. X minus y will be equal to 3. Likewise, if the y is incremented by 1 up to your total demand is 3. So that's why we did this only up to a point 3. Now I will write this formula as, therefore we can write what is your formula? F2 of 3 will be equal to minimum of y. Now I will write it here. I will put the value of all these cases. When y equal to 0, then x minus y equal to 3. Then you can write y equal to 1, then x minus y equal to 2. So likewise I will write it here. So what it will be? It will be what? In a bracket I will write F2 of first case y equal to 0. So I will take it as a 0 plus capital F1. What is this? Is your x minus y. So what is your x minus y? X minus y will be 3. So F1 of 3 comma. Now take the next pair, small f2. Now this will be the pair 1 plus capital F1, okay, of 2. Why? Because x minus y is 2. Then next I will write for the next pair. Now what is the value of y? Put here y equal to 2. So what you will get? It will be what? F2 of 2 plus capital F1 x minus y. What x minus y comes out to be? It will be 1. So x minus y is 1. So it will be 1 comma small f2 of, now take this as a 3 plus capital F1 will be there here of 0. So what we have to do? We have to find it out answer for this, and whatever will be the minimum value, consider that minimum value, and we have to take the combination of a units. So how we will do it? Please see it carefully. Now it is, first I will find it out. I will write it here as A. What we have to find it out? F2 of 0. Now what is the equation of F2? It is already given to you. What was that? 1.2 P2 square plus 22 into P2. So therefore now I will substitute the value here. What is F2 of 0? It will be what? 1.2 into 0 square, because we are going to put this value here. 0 square plus 22 into 0, which comes out to be what? Which comes out to be 0. Don't write here unit. It will be 0. Now I will take second combination is F1 of 3. Now what you have to do here? Here this is the value of n equal to 1. So what is the equation of first unit? Equation of first unit is 0.8 P1 square plus 25 into P1. So we will do it. I will put it here 0.8. Now what is the value of power here? Value of power is 3. So 3 square plus 25 into 3. So if you solve this, you will get answer as 82.2. Then third one is nothing but, so if you see here, we completed this parameter, this parameter. What is next? F2 of 1. So I will write small f2 of 1. What is the equation here? 1.2 into 1 square plus 22 into 1. So answer comes out to be 23.2. Next is what? Next will be capital F1 of 2. So what is the equation of F1? 1 unit is equation 0.8. Now here we will put this. So it will be what? 2 square plus 25 into 2. So what you will get? The answer is 53.2. So we covered these two. Now we have to do for this F2 of 2. So I will write small F2 of 2. How you can write? 1.2 2 square plus 22 into 2. So answer will be 48.8. Again I will do it for, now this F2 of 2 is over. Now this will be F1 of 1. So I will write it as F1 of 1 will be equal to, what is your F1 equation? It is 0.8. P1 will be equal to what? Sorry, P1 will be here 1. So 1 square plus 25 into 1. So what will be answer for this? If you calculate, you will get answer as 25.8. A, B, C, D, E, F. Here I will write at G. So we covered up to these 2 points. Now we have to find it out F2 of 3. So what will be F2 of 3? So I will write it here. F2 of 3 will be equal to, what is the equation of F2? F2 equation is given 1.2 P2 square plus 22 P2. So I will write it here 1.2. Now P2 square means what? This we will put here 3 square plus 25 into 3. So what you will get answer, it's not a 25, sorry, it is 22 into 3. So what you will get answer? Answer is nothing but what? This will be 76.8. and I will go for last one is nothing but what? If you see in here, last one is capital F1 of 1. So I will write it here as capital F1 of, not 1, sorry, capital F1 of 0. So what is the equation of F? It is 0.8 into 0 square plus 25 into 0. So what you will get here? You will get answer as a 0. So what we did here, we have find it out. We have taken the cost equation and we put there how much megawatt it is going to be produced, and we have find it out. Now from this expression, from this equation, how I can write? I can write it like this. So let me write this first. How I can write? Therefore F2 of 3 will be equal to minimum of Y. Now please add this term. What is there? F2 of 0 plus F1 of 3. F2 of 0 is 0. F1 of 3 is 82.2. So if we add this, what you will get? Answer as 82.2. Next is what? Next is F2 of 1 plus F1 of 2. So F2 of 1 is 23.2. F1 of 2 is 53.2. So if you add these two, then you will get answer as a 76.4. Next is nothing but what? F2 of 2 plus F1 of 1. So F2 of 2, what is the value? 48.8. F1 of 1 is 25.8. So if you add these two, you will get answer as 74.6. And last but not the least is nothing but F2 of 3 plus F1 of 0. So you add these two. So what you will get? You will get answer as 76.8. Now what is the meaning of this expression? We have to choose that value whose value is minimum. So whose value is minimum here? If you see 74.6, this is the minimum value of, or you can say cost of the generation. This 74.6 is achieved when we have a set of this, because this is a third value here. This is first, second and third value, minimum value. So and this will be what? So what is the third combination? F22 plus F1 of 1. So therefore how I can write? I can here write it as, therefore F2 of 3 will be equal to what? F2, small f2 of 2 plus, here you will see capital F1 of 1. So I will write it here, capital F1 of 1, whose cost of generation is 74.6 rupees per hour. Now what is the meaning of this? Now it is observed that, what we observe, initially we have find it out this. Initially, if you remember, here we have find it out answer of F1 of 3. What it was? It was 82.2. So I will write it here. The answer of F1 of 3. Meaning of this is nothing but what? 3 megawatt is going to be generated by unit 1. If all the 3 megawatt is going to be produced or the load is load is served by only one generator, then its cost of generation is 82.2 rupees per hour. But if we have the combination, how the combination will be? This combination F2 of 3, it should be in such a way that F2 of 3 means what? Both the generators will produce 3 megawatt, and in that how much share one unit should take, that we have find it out here. F2 of 2 plus capital F1 of 1, and total cost of generation of 3 megawatt by combination of these two units is 74.6 rupees per hour. What you observe here? It is observed that only use of one unit for production of 3 megawatt takes the cost of generation 82.2. But here if we take a combination of two units, and out of which, now please remember meaning of this. The meaning is nothing but what? Whatever term which is shown in the bracket, it is a megawatt. So 2 megawatt by this 2 is nothing but what? This 2 is nothing but unit 2. So how the you can say how the discrimination will be, how the 3 megawatt is going to be shared by both the units. 2 megawatt should be produced by unit number 2, and this 1 megawatt should be produced by unit number 1. This is your unit number 1. Because if we use both the generators, then the cost of a generation is minimum, and this is what is our motto: cost of the generation should be minimum. So therefore we can say that, or the comment is, it is observed that in order to generate 3 megawatt of load, minimum cost of generation is 74.6 rupees per hour, and which is the combination of unit 1 and unit 2. Here 2 megawatt should be produced by unit 2 and 1 megawatt should be produced by unit 1. This is the problem of dynamic programming. It is very easy. If you have any doubt, please feel free to ask any questions. Thank you for watching this video.